Okay, so our first talk for today, it's the FinCausal shared task by Dominique Marico. So Dominique is from Easyop AI company, and she's going to start presenting her work now. So Dominique, if you want, please go ahead and start.
Okay, so hello everyone. You hear me? Yes, fine. So just I'm going to make a quick introduction to the FinCausal shared task this year. So this shared task is a follow-up session of causality extraction pipeline that was proposed as a shared task also last year alongside FNP, FNS at Calling. This year we reproposed only the second task, which is a causality extraction task. We assumed the first part of the pipeline, which was defining if a text chunk was causal or not. So binary classification task was solved last year. And this year we proposed only the second one, which was assuming a section of text contains a causality. Can the participant try to extract the cause, distinguish between the cause and the effect? So I'm going to go very quickly on the creation of the data set. We have a whole paper. I'm sorry, we ask you to refer to that if you want to know more on how we created the data. But one of the questions we had to ask when we created the data set is, what are the events that we want to consider the causality for? So we decided for so-called quantified facts, which in fact are indicators values in most of the time, so we could define causal chains from them. The second question we had to answer was, what are the causality that we want to model? Because most of the time causality is expressed in a very explicit fashion, which is, for instance, you have a connector such as because, or so that you know exactly where the causality is located. But you can also have implicit causality, meaning the causality can be spread, for instance, across one sentence without a connector, or within a chunk of text containing multiple sentences. And the third causality we wanted to explore is, we noticed that sometimes in a text chunk you can have multiple causes for an event or multiple effects, and it's led to the definition of multiple causality, which is quite the remaining challenge in the task. So the dataset looks like this. You have, for instance, chunks of text, which is, you take the last one, which are what we call unicausal, meaning we extracted only one causality, one cause and one effect in a sentence, and multiple causalities given. So these are the first two examples, where you can assume that you have a multiple causal chain in the text chunk. And so we try to propose this possibility and see if we can find systems to extract these causalities. So I'm going to go quick on the results because the participant will be in a poster session this afternoon if you want to go and meet them. We noticed a few things. So first of all, interesting stuff. Some participants built on the systems that were proposed last year and try to improve them. This is the case for the winning system, for instance. Second interesting stuff is that some participants worked really hard on optimizing the exact match metric. This is the case for the second best system, and they indeed achieved the best exact match score. One thing that actually kind of bothers us is that we also notice, because each year we ask the participant to share their training device so that we kind of sort of have an idea of the computational power they train this system with. And this year we noticed that the size of the training devices tend to increase. And at this point we kind of wonder if the system is the system really improve the results, or is it due to the size of the training device? So Fiona, who is going to give our talk just after, who won the task this year, did something very interesting. She built on the last year winning system, and in her benchmark, she retrained last year's winning system with her own device. And doing so, she gained up to 0.8 F1 points, which is she's over a 95 and 50 for retraining last year's system with our GPU, which is already very good. So you see, this is we start having this kind of questions on, can we really improve the systems, or are we just adding more computing powers to solve the problem? And one last thing, it's the third ranked team who actually questioned in a very interesting way the metrics. He showed that there was a persistent discrepancy between the F1 score and the exact match. So this is due to two things. First, the metric we choose for F1 precision and recall is a weighted metric. And the second thing is the exact match is a sort of pass or fail test, meaning it's computed on tokens in a sentence, causal or not causal. And if you don't have the exact causality extraction chain, you have a zero exact match metric. So this is why you can have a good F1 score and a terrible exact match metric. And at this point, we also wonder if we were to, so we consider that the implicit causality problem is kind of solved. What is not solved is the multiple causality extraction problem. And we are not sure that we can actually solve this either with the data set we have, because we have over only 300 examples of multiple causality, over 3,000, which is really small. And second, we don't know if neural models or in a more wider way, machine learning models can actually solve this problem, because they tend to provide repeated patterns. And we ask them to find two different solutions on the same original text chunk. And at this point, we are not sure that the remaining 5% or 4.5% can be won with neural models. But I'll let you discover the systems of the participants yourself if you have questions for them. They'll be available this afternoon. And well, thank you.
Thanks very much, Dominique. That's actually very exciting.
Sorry.
Before we start with the next talk, I have one question. So what do you think is the future for FinCausal?
I don't know, because honestly, if we were to propose something accurate, we would have to change the metric, because I'm not fond of the exact match metric. It's interesting, but it's too definitive. I'm not sure it helps in improving the system. For instance, is this DSC team succeeded in improving their results, only optimizing the, not only, but really working on optimizing the exact match metric. But even so, they were blocked at some 95 something F1. So either we would have to change the metric, maybe using some translation metrics, and augment the dataset for multiple causality.
It's cool. I mean, the results are highly competitive. I mean,
yes,
they're all above 90. So yeah.